We could play around with administrative distance if we wanted to. But I'd like to show you another way, route tagging. How many of you have done route tagging before? What is it? Well, it's the process of tagging a route or tagging a group of routes. So that way there we can call upon those routes or route later on by the tag. And then we can manipulate values in that route. We could filter that route. We could do a lot of different things just simply by calling upon that tag instead of calling upon the route itself. It's kind of like those wilderness shows that you see on the Discovery Channel where they capture some animals in the wild. Not for malicious intent, no, for good, because we have scientists who want to analyze these animals, and they want to see how are they faring out right now based on different changes in the world. So they tag the animal with an identification, and they measure the animal, the length, the height, the weight, and they gather vital statistics about the animal, and they store it in a database, and the animal is now identified by this tag it's given. And let's say 5 years from now, they are back in the same area or in a different area, and they capture the same animal. Well, they have an ID, that tag, and they know that they've had that animal before. And then they can compare it to the database and see if things have changed. Well, in this case, we're not looking for change. We're looking for ways to call upon these routes by that tag, so simply by that identification number, and then maybe manipulate the route, filter the route, do different things with the route. So if we look at this example here, what do we have? We have a prefix list. And this prefix list is permitting the default route, 000/0. So all of that work you have done on prefix lists helps you out with this. Because you can easily read this now and you're saying, oh, this is an exact match to that default route. And then what are we doing? Well, we are creating a route map that we're naming set tag. And it's a permit. And since we're going to be attaching this to redistribution, permit means redistribute. And so while we're redistributing, we're going to redistribute the default route, 000/0. And when we do so, we are going to set a tag of 40. We're going to set a tag of 40. Now remember that the default, route map, the default behavior of a route map is to what? Top-down processing, immediate execution upon a match, implicit deny all at the end. So the route maps that are attached to redistribution, by default, at the very end, they are stating, do not redistribute. So we need an extra sequence here that's going to allow everything else to be redistributed. Because if we don't include that, then we're only going to be redistributing that default route. So if we focus our attention now to the redistribute command, it says redistribute EIGRP 100 and attach to that route map set tag. So we're redistributing everything based on this route map, but specifically the default route's going to get a tag of 40 while it's being redistributed. And we can see that in our example here on R1, there's that tag of 40 that's being applied to that static default route that's being redistributed. Well, in this case, it's not the static default route anymore. It is the default route that R1 learned via EIGRP. On R2, it was a static route that was being redistributed. But R1, no, it is the EIGRP learned route. So it has a tag of 40 now. And let's follow it around. The tag of 40 comes back around and it says filter. So let's look at R4 now. If we go to R4, I want you to notice our route map down here called deny tag. It's a route map that is denying. We can see here, deny, right here. And it's saying match tag 40. Now, as we've stated before, how you apply a route map determines what permit and deny means. So we are applying deny tag to a distribute list. So this distribute list is attached to route map deny tag inbound. And what it's stating is do not accept the default route or do not accept any route that has a tag of 40. And in this case, it's the default route. But let's be a little more clear here. we are dealing with OSPF. And with OSPF, I can't explicitly filter routes coming from neighbors because we all have to have the same link state database in the OSPF area. So what am I doing here with OSPF? Do you remember from a previous discussion? We are filtering what is installed in the routing table from the link state database. Not what we learn from routers, it's what we install in our routing table from the link state database. So in this case, I am preventing the route with a tag of 40, which in this case is who? It is going to be the default route of 0000/0. It's going to have a tag of 40. So if you went to the operating system, the Cisco iOS, the command line interface, and you typed in show IP route 0000, in that output, that's where you would find the tag. It would be listed there. You can see that tag. You can also see the tag in the OSPF database, show IP OSPF database. You can either see the tag listed right in the database. You can also open the specific LSAs and see the tags inside the LSAs as well. All that information is available there. So we also want to do it in reverse. So from R4, same prefix list, the default route, setting a tag for the default route, but in this case it's 20. And everything else is just going to be redistributed. We're applying it, redistribute EIGRP 100 route map set tag. These route maps don't have to have the same name, folks, between R1 and R4. We just did that here in our example. And then, if we go back up here to R1, notice what it says, route map deny tag. Deny. Match tag 20. We apply it to the distribute list, and the distribute list says the route map is deny tag in. So do not allow the route with a tag of 20 to be installed in the OSPF database. Or, pardon me, do not allow the route with a tag of 20 to be installed in the routing table. It'll still be in the OSPF database, it just won't be in the routing table. Thanks for letting me clarify that. All right. So what does this mean for R1? Well, it means that R1, and it will no longer be installing the default route that is being learned through OSPF. So since that is not in the routing table, it's not allowed to be in the routing table, what is the other option it has? The other option it has is the route learned via EIGRP with the administrative distance of, that's right, administrative distance of 170. So that's what R1 is going to install in its routing table, simply because there is no other option to install. We have filtered out the other option, the OSPF option. Same thing with R4. R4 is no longer allowed to install that OSPF learned option, so it's going to install the route learned via R2 in the OSPF, in the EIGRP domain with the administrative distance of 170. So we've solved our problem. We've solved our problem. We are now still going to redistribute. As we can see, we're still going to redistribute in, which is important. So that way their R3 will definitely learn the information. R1 and R4 will learn the information as well. However, they will not install it in the routing table because we're preventing them from installing it in the routing table. And as a result, we have solved our problem. We've solved our environment that's constantly flapping and changing through the use of route tagging.